Hello everybody. Today we go talk a little about Messenger queue in streaming architecture patterns for delay process of messages. So what's the difference and how we can use it? So for example, we have queue. What and when we use queue. Queue is a service for process messages and specific messages that is consumed by the own service that incubate this message. For example, if you have a queue, you have a web server. Web server, for example, have a high throughput here. I will high throughput, high latency service. For example, our web service calls a high latency service, and this is increasing the latency of a server. We want to process in background this kind of feature, so it's possible to do it too. So what we do, we encrypt a message to do this job, and our web server only call this queue serves to enqueues the job to do this work. So this the the server that consumes this job enqueued should be called something like workers or consumers. Is a common names for this kind of job when he only consumes a queue. We have a lot of services that to provide this kind of feature, this kind of service. One of it is the AWS Simple Queue service. I love it, this service by all. Have RabbitMQ. All of these services have similar features, that is to enqueue and to process some jobs. So it's common you see these two services. For Ruby developers have to the Sidekick, that is the greatest library for small projects and medium projects too. For process delay jobs, it's very faster and based on Redis. So you need to start a Redis to start your Sidekick. It's a very common architecture. I love AWS SQS. I have I have a feature that I love because I think that works well. That's called visibility timeout. So what these features mean is that when you have a message here and this a message, I include this message. For example, if I process this message, when my worker got this message, I will apply a visibility timeout in message in 30 seconds. So for 30 seconds, my workers can't receive this message again. So if I need to guarantee that my workers performs and done well the job in 30 seconds, or I can delete the message before be processed to avoid this message was re-enqueued or reprocessed by my workers and consumers. I like this kind of feature works well, so I like this way that SQS guarantee that the message will not process it twice, uh, uh, not without you expected it. So so uh, the queue in resume is used for you process a message once and have a particular thing that queues can support. Two is FIFO queues, that is first in, first out. The first message that be Scheduled is the first message that be processed. So the queue service need to support it, so it can be a problem for high throughput applications, because normally this message, when you have a FIFO queues, you can't process in parallel. So it's normal and it's good this visibility timeout, because suppose you have a one queue that have a great number of messages, and you have a lot of workers that consume the same queue. So the visibility timeout, or whatever other feature that you guarantee that the job will be uniquely processed between a lot of workers calling receiving messages from the same queue. It's a great important feature to high throughput applications. So we have the second example, that is the second architecture, that is a messenger. What's messenger? Messenger is a structure that you have some topics, and these topics have subscribers. What subscribers? Subscribers is the services that want to have the information that is posted on topics. For example, you have a product service here. I have a product, for example, and my product service published a product. So I have a product published, and the ID of my project is 1. So I have this message. What services need to know? Messengers is common on microservices architecture, because they communicate is a way to communicate a lot of services with the same information, without need to do many rest or many queue jobs, and is a great architecture to maintain the architecture simple for your application. So you have the product published, so you have a lot of services too, like search. You have the inventory or the stock service. You have a counters service, for example, to increase, decrease. So here you need to pass this info of product published to all these services. So in our structure, what we are calling here, our topic will be product, and will be product published. So our subscribers for the event of product published will be search, inventory, and counters. These services will receive this message in whatever way. AWS and SNS is a service, for example, that do this kind of job. This service here is a service of PubSub. In SNS, you can use, for example, like this search will receive the message via webhook. the stock will receive via a SQS, and the counters will receive via a Lambda trigger. So this kind of service tends to be very modular because of how they can work with a lot of microservices. So this kind of how will be subscribed is is related of each microservice and not related with the messenger. So the messenger receives messages you and publish to the subscribers that this publish should be called as broadcaster too. So it's very a very interesting architecture to you know and to you deeply your knowledge about. So this messenger, when you work and when you call about microservices, is too common too, and for me is one of the requirements to a good messenger service. You have and store all events. What is it? For example, I have this product published with ID 1. In my job, in my publisher, I will store it with message ID, for example, and a hash. Okay. I have another message that have other hash. So for me, it's required that this kind of service you can redrive since a message. What it means? If I want to redrive my messages from this hash, I redrive all my messages sequence with this hash. So my microservice understand that is in it hash, and if I receive a message before it hash, I only discard this message, or I can or I have the possibility to check if I'm in the mostly updated events schema for that of that topic. For example, this is good for when you have a microservices architecture and you need to start a new microservice and you need to check for all products published event. You need to do some actions, and you have all storage events. You only redrive, and your microservice need to have the correct behavior to redrive these messages. This is a not common way to develop application. So when you work in a, a, a event-based architecture, you need to have this mindset. And the last one is the stream. Stream is have a particular usage. Stream is for real data processing. What's real data processing? For example, if you have logs, you can put in a string. If you have analytics data, you can put in a string. If you have videos and media content, for example, video, audio, or whatever media content, you put in a string. And how it works. String tends to create a partition key. I only have experience with Kinesis string, so I will say my vision relative with Kinesis and how Kinesis work. So we have the partition key. This partition key, for example, should be a key when I open a video on YouTube, for example. So if I open a video on YouTube, my partition key should be this partition key. So all my parts of YouTube video, I will open a connection with stream. For example, I have my client here. I will open my client connection with stream that will be here. For example, the server of YouTube. This connection will be opened and YouTube will send messages over the string of partition key here. Remember that the partition key is used to guarantee the order. Why it? Because I can't receive a video frame before receive a older frame. If this occurs, my video will not make sense. So this partition key is used to guarantee this order. So it's the reason of it exists. And video should be real time, or can be real time. You can't receive the whole video, so you will receiving with parts. These parts you are receiving from a given partition key. So this is the way how a stream can be used. So it's common all stream services have partition keys or similar names that guarantee the order to change messages between the consumer, the client, and the provider, that is the server, that is the shard, that is the server, and that owns this content in there giving to you. So have some particular things like the string should be opened by a WebSocket and other architecture uh, uh, architecture tool to receive frequent data on a client HTTP, for example. So this is a very common usage for processing videos, and logs is the same thing. It's natural you have some order in logs, so mainly on analytics logs, you need to get a order of events for a user. For example, you need to maintain this order, and this order is maintained by this partition key. So I think that is it. If you like this video, I apologize for mistakes of English, and thank you for watching. Bye bye.